integers. Okay, non-fractional numbers. Negative numbers are allowed, 0 is allowed, but fractions are not allowed. So we can write a proof like this. Okay, while writing the proof, let us carefully note how we go about the proof. First of all, almost every mathematical statement looks like this. Any mathematical theorem looks like this. This part is hypothesis, this part is the conclusion. Or, in other words, we are trying to prove this. Is an even integer. This theorem is of this form, x implies y. Or you can sometimes have theorems which are of this form. X and y are logically equivalent. This is stronger. These type of theorems are stronger. Okay. So what should we do? We first assume the hypothesis. Assume n is an integer, or you can also write that it is given that n is an integer. That way also will work. Assume n is an integer. Being an integer, n is even or odd. Recall definitions of even and odd integers. Even integer is an integer that is divisible by 2. For example, these are even integers. 2, 4, 6, 8. And odd integers are integers that are not divisible by 2. For example, minus 5, minus 3, minus 1, 1, 3, 5, 7. These are odd. These are even. Together they make the collection of all integers. Okay. So we have assumed n is an integer. So n can either be even or odd, but not both at the same time, of course. If n is even, then so is n times n plus 1. If n is divisible by 2, for example, if n is equal to 4, then n into n plus 1 is 4 into 5, that is also divisible by 2, because 4 itself was already divisible by 2. So whenever n is even, so is n into n plus 1. And you can see that that is the conclusion. Okay. But there is one more case. If n is odd, n can be odd also, then from the properties of integers we know that n plus 1 is even. When n is odd, for example, if n is 1, then n plus 1 is 2, which is even. This is always the case. But then n into n plus 1, since n plus 2 is even, any multiple of it, any integral multiple of it is again even. So then this is even. So in any case, n into n plus 1 is an even integer. So that concludes the proof. Now, why have I proved this result out of nowhere in a discussion about mathematical logic? Now we come to the important point. So you see this result, it has actually two parts depending on whether n is an even integer or an odd integer. So essentially we have proved this. Essentially we have proved this. When n is an even integer, then n into n plus 1 is an even integer. This is one thing we have proved. Also, we have proved when n is an odd integer, then n times n plus 1 is an even integer. Okay, so these two things we have proved, and in fact the original statement consists of these two things, since n can either be even or odd. Okay, now consider this. For a particular value of n, for example, say n is equal to 342, a somewhat large value of n, what part of the theorem or what part of the proof that we have written